Hello, ladies and gentlemen, boys and girls. Let's watch a little video over I-5 division by complex numbers. I'm going to tell you this is going to be somewhat complicated. You may have to watch this video a couple times. You may have to pause the video. I'm going to put as many examples as I possibly can in a 10 to 15 minute video so that you have ample examples and then know that this particular IXL is due by tomorrow. So what we're going to do is we're going to divide by complex numbers. And the first few are going to be fairly straightforward. If I have 5 over I, so we don't want any i's in the denominator. So how do I get rid of that I in the denominator? Well, I'm going to multiply by this creature I over I. Because real numbers or complex numbers, I over I is 1. So I'm allowed to multiply by 1, and that's exactly what I'm doing. I'm just multiplying by 1. And what's that going to give me? That's going to give me 5i over I squared. Well, we know what I squared is. I squared is -1, so this is 5i over -1, which is simply going to be, and then the whole thing, positive divided by negative, is going to be -5i. Example 1. Another example, same nature, only a bit different. If I have 7i over 3i, well, the i's will just cancel, and that is simply going to be 7/3. There's going to be some very easy problems similar to this, and some next step problems. Let's do another problem like this example. There are going to be problems like this. We're going to do another one like this. So here you go. Let's go -2 over 3i. Well, I want to get I out of the bottom. So I'm simply going to multiply by I over I. And that's going to get the I out of the bottom. And what's that going to be? That is going to be -2i over 3i squared, I times I. And we know what I squared is. I squared is -1, so this is going to be -2i over 3 times -1. Negative divided by negative is positive, so that's going to be 2i over 3. This negative and this negative makes the whole kit and caboodle positive. Okay, those first 3 examples are not bad. Now we're going to delve into a bit more complicated problem. And I'm going to do the example here. Here I have 2 plus 3i over 4i. What you want to do with these types of problems, what we're going to do is we're going to rewrite that, and we're going to make it look like the complex number a plus bi. We want there to be a real part and imaginary part when I get finished manipulating that. Okay, so what I'm going to do is I'm going to multiply that. I need to get that I out of the bottom, and just like I did before, I'm going to multiply this whole kit and caboodle by I over I. Okay, now I'm going to use the distributive property, and I'm going to take I and multiply it by that binomial there. And I times 2 is 2i. I times 3i is going to be positive 3i squared. And then I'm simply going to multiply this I times 4i here. And what's that going to be? 4i squared. Now, wherever I see an I squared, I'm going to put a -1. Not finished with that yet. So now I have 2i minus 3 over -4. Now, since I have both, since I have division by a -4, what I'm going to do is I'm going to split the top up and write both of them over -4. So that's going to be 2i over -4 plus -3 over -4. And I'm almost there. Okay? Negative divided by negative is positive. Positive divided by negative is negative. 2 divided by 4 is 1/2. So this is going to be -1/2. I still have the I there. 2 divided by 4. 2 is 2 times 2. 4 is 2 times 2. One of the 2's cancel. Positive divided by negative is negative. Negative divided by negative is positive. But now I want to write it a plus bi, and I'm going to write it as 3/4 plus -1/2 I. And that certainly doesn't look like that. So this is one that you're going to have to really be careful on. So this is 2 plus 3i over 4i does indeed equal to 3/4 plus -1/2 I. Okie dokie. That's certainly one way to do this one problem, but I'm going to show you another way to do this problem too. What I'm going to do here, let me extend. I'm going to take and right away split this guy up to 2 over 4i plus 3i over 4i, and a lot of students elect to do this way. So now look at this piece right here. In this piece, the i's will cancel. This piece right away, I'm going to say, hey, 2 divided by 4 is going to be 1/2. So this right away is going to be 1 over 2i plus 3/4. Uh-oh. So we're almost there. So all I have to do now is to take this I and get him out of the bottom. And what am I going to do? I'm going to multiply this one thing here by I over I. I don't need to change this guy at all. He's just going to still remain 3/4. And look what I have here. I have I over 2i squared plus 3/4. And what's I squared? -1. So this is going to be 3/4 plus -1/2 I. And that's the same thing I had. So there's two ways to get to the simplified version of that. So let's do another one. Alrighty. Let's do a tad bit more. And keep in mind, you may have to pause the video to go over that. Alrighty, so let's do another example like that. Let's do, so here's another example similar to that. 3 minus 4i over -5i. What I'm going to do is the second method. I'm going to start off by splitting both of those up. This is going to be 3 over -5i plus -4i over -5i. Now the i's cancel here, and this second part is simply going to be 4/5. And I'm going to write that because keep in mind, I want to write everything in the form of real number plus imaginary number portion. So this is going to be my real number portion. -4i divided by -5i is simply going to be 4/5. And I still have this guy here over here to contend with. And how am I going to deal with that? I'm going to simply multiply that by I over I. And what do I have here? Then I have 4/5. What do I have? 3i, 3 times I, over -5i squared. Well, what is I squared? -1. So this is going to end up 4/5. -5 times -1 is 5, plus 3/5 I, positive. So that's another example for that. Pretty good example. I have to look at that one a couple times, or pause the video and write it down. Rewatch the video. So now we're going to look at some examples that you cannot split up. Say I have 5 over 2 minus 3i. I can't split that up. I can't write that 5 over 2 and 5 over 3i. But I'm still going to do something, and I want this to end up looking like a plus bi. I want it to be a complex number with a real part and a complex part. What I'm going to do, and this is not going to be difficult, it's going to be kind of, you will become adept at this eventually. I'm going to look at the conjugate of the denominator, the conjugate of 2 minus 3i. And what is the conjugate of 2 minus 3i? The conjugate is going to be 2 plus 3i. Those are conjugates. So what I'm going to do is I'm going to multiply top and bottom of this guy to the conjugate of the bottom. So here's what I mean to do. I have 5. Let's do it in something you can see. I have 5 over 2 minus 3i. And I'm going to multiply that by 1 in the form of 2 plus 3i over 2 plus 3i. That's 1. And look what I did. I simply took the conjugate of the bottom. The top is going to multiply out fairly simple because it's just a distributive property. 5 times 2, 5 times 3i. So let's do the top first. This is going to be 10 plus 15i. And now what I need to do is I need to multiply 2 minus 3i times 2 plus 3i. Let's go over here and keep in mind that's what goes on the bottom of this right here. And so let's come over here and do this multiplication separate. Let's go 2 minus 3i times 2 plus 3i. And we're going to use the FOIL method on this because we're multiplying by items, two factors of 2 terms. So I'm going to go first. 2 times 2 is 4. I'm going to go to the last, or the outside. 2 times 3i is positive 6i. So I have 2 times 2. 2 times 3i. Now I'm going to go the inside terms. And I'm going to go negative 3i plus 2, which will give me negative 6i. And now I'm going to go negative 3i times positive 3i. And what's that going to be? Negative 9. 3 times 3, negative times positive is negative. 3 times 3 is 9. I times I is I squared. Well, something magical happens here. If you look, the 6i minus 6i, they cancel. And so I have 4 minus 9i squared. Well, what is I squared? Negative 1. So this is going to be 4 plus 9, because negative 9 times negative 1 is positive 9. So the bottom multiplied out is going to be 13. I still don't have the final answer in a plus bi. So what I'm going to do now is simply divide this up. You can divide a fraction up if you have a single term on the bottom. So this is going to equal 10 over 13 plus 15 over 13i. So it doesn't look like this, and this is probably one of the more complex problems. So this rascal right here, 5 over 2 minus 3i, turned out to be 10 over 13 plus 15 over 13i. So this is an IXL that you certainly will want to watch this video over. Take some good notes before you attempt it. Let's do another example like this. Okay, let's do a simpler, well, doesn't matter. Let's go 2 over 3 minus I. I want to write that A plus BI. What am I going to do? I'm going to take this rascal and I'm going to multiply the top in the bottom by the conjugate of the bottom. So I'm going to multiply that by 3 plus I over 3 plus I. Okay, let's multiply the top out first. I have 2 times 3, 2 times I. Looks like that's going to be 6 plus 2I. Now I'm going to multiply the bottom. So I'm going to multiply 3 minus I times 3 plus I. I'm going to FOIL that rascal. 3 times 3 is 9. 3 times positive I is positive 3I. Negative I times 3 is minus 3I. This is going to happen every time if you multiply a complex number to its conjugate. It will happen every time. So then I have negative I times positive I is negative I squared. Well, we know what I squared is. Well, the first thing we need to realize is those guys cancel to 0. And what do I have on the bottom? I have 9. Negative 1 times negative 1 is plus 1. So the bottom becomes 10. And now, since I have a single term in the denominator, I can make this 6 over 10 plus 2 over 10I, and I'm going to reduce these fractions. The correct answer there will be 3/5 plus 1/5 I. So this probably is more of a difficult, I think, IXL. You're going to need to practice. If you get the answers wrong, please watch the tutorials from IXL. This will be very helpful, and this will be an assignment. So make sure you can get to as close to a 90 as you possibly can on this IXL. Okay, Toki. If there are no further questions, I will bid you good day.